All right, so let's look at our examples. Okay, the first one says the semicircle in the diagram below has a radius of 4 centimeters. Okay, so there's their semicircle. What is the area of the shaded region? Well, we can see it's a composite shape because obviously it's made up of more than one shape. Now, it's like taking this whole big shape, if I knew what it was, and taking a big bite out of it. Okay, or I could look at these triangles they have here, but if I look at them, my problem is, then how am I going to find this shaded part here? I could get that as well, but I'm thinking if I knew what this big shape was and then subtracted that semicircle, that would be my best bet. So I'm going to call this big shape shape 1 and the semicircle shape 2. Now this big shape actually, if I draw it kind of like this, I'm not doing straight, that was yucky, wasn't very straight lines. Um, it looks like one of the shapes from the previous page. And if I look at it, it looks like a trapezoid, doesn't it? It looks like a trapezoid, but do I have a right angle thing? And it says this is supposed to be parallel. So let's go look back at this shape that they're looking at here. Well, notice that they have given me a right angle here, dropping down. So do I have enough information to find that? Well, actually, that's the same height as here, which would be a radius. So we know this. Now, is it a trapezoid though? Because I don't see any parallel lines here. But let's take a look at it. We have two right angles here. And from there to there is also 4. So it is, even though they do not have those on here, it is a trapezoid. So I'm going to take a trapezoid and I'm going to subtract half of a circle. Now, that is my little diagram to help me remember my plan. So I'm going to find the area of the trapezoid first. Okay, so, oops. So if I look at the area of a trapezoid, I think I spelled it wrong. You have to excuse my spelling. Trapezoid. Okay, if I look at that area of a trapezoid, if I go back and look, it says I need to know A plus B, multiply it by the perpendicular height, and then divide by 2. So let's take a look. I know this here is 14 all the way across, but what about on the top here? Can I figure out that top? Well, I think I do have enough information for that. That top, if we look back at the question, the top consists of from here to here, which is 4, and from here to here, which is another 4. So actually, that top is actually 8. And we already talked about the perpendicular height, which was 4. So I have enough information to fill that in. So that's what I'm going to do. So it is the same as 8 plus the 14. Then I need to multiply it by the perpendicular height, which is 4, and then divide by 2. Okay, so depending on how much you're going to do in your head, so that's going to be 8 plus 14. So we're looking at 22 times 4 divided by 2. So that's the same as 11 times 4. So it's actually 44. Now, if you can't do it in your head, then you know your next best bet. Okay, so that's the area of the trapezoid. Now I want the area of the semicircle. And I literally would put area semicircle. I would put that English there so that people know exactly. I'm not doing it just to make you fill something out. It truly helps your communication mark. Okay, so I know the area of a circle is pi r squared. My problem is I only want half of it, so I'm going to put a half in front. Or I could put it over 2 if I wanted. So I have 1/2 of pi times the radius, which they told me is 4, and I'm going to square it. Okay, so that's the same as 16 times a half, which would be 8 times pi. And I do not do pi in my head. I'll be perfectly honest, I do not. So up comes a calculator, clear of its information. So 0.5 times pi. Now on my calculator, I know where pi is. Actually, notice it actually put pi in there. Times the 16. And it tells me it's 25.1 roughly. Now I'm not finished because remember, this was my plan. I was going to take the trapezoid and I was going to subtract the semicircle. So the total area that I want, so I'm going to put area total, even though I'm subtracting and total often means adding, is going to be the 44 minus the 25.1. And again, you can pull out a calculator if you want, or you can do it in your head like I'm having to do. So that's 18.9 centimeters, and we're talking about area, so it is squared. Okay, next question. Next question. We did some of these, some things like this before. So the perimeter of the triangle below is 75 meters. Okay, that's fine. So if I add everything up, it equals 75. Determine the measure of each side of the triangle. Okay, so my issue is here I have to take each side, add them together, and it has to equal 75. The only difference is what I'm dealing with are little polynomials. So each side has its own polynomial value. So the first thing I'm going to do is I'm going to do 75 equals and perimeter. So I'm going to start with 3x plus 4. I'm going to add 2x plus 9, sorry, minus 9, and 2x plus 3. So we're literally taking each one of those sides and adding them together. Okay, so this is like gathering like terms. What things go together? Well, the 3x, the 2x, and another 2x. So I have a total here of 7 x's, and I have 4 and 3 is 7, minus 9 is negative 2. I'm going to add 2 to both sides. So I end up with 77 equals 7x. How do I get rid of the 7? I divide by 7 on both sides. So I end up with 11 equals x. Now, I'm not finished because it didn't ask me to solve for x. It said determine the measure of each side. So now I have to take that 11 and substitute it into each one. So I'm going to do that below here. So I'm going to take the 3x plus 4, and I'm going to substitute in the 3 times 11 plus 4. So we have 33 plus 4, so we have 37, and it's meters. Our other side, 2x minus 9. Again, substitute 11 in for the x. So we have 22 minus 9, so we have 13 meters. And finally, we have 2x plus 3 equals 2 times 11 plus 3, which is 22, plus 3, which is 25. Now, if we've done it correctly, if we add all of those three numbers together, we should get 75. Okay, last question. Ooh, nice doozy one. Okay, so the first thing, now this one doesn't tell us what we're supposed to do, but I think we're going to find the perimeter of this one if you don't mind. So perimeter equals, okay. So, or we could do area, it doesn't really matter, but let's take a look at, first of all, our perimeter. Okay, 2 ticks stands for 15. Anywhere there's 2 ticks. Okay, there it is there. 3 ticks equal 9. There's 9. 1 tick equals 11. There's 11. there's 11. And my problem is I don't know what this equals. Okay, so from here to here is 11. From here to here is 11. And from here to here is 11. So actually that bottom actually equals 33. So my perimeter here is going to equal, okay, and I'm going to start at the bottom, and I'm going to go counterclockwise. So 33 plus 15 plus, you could count all the 11s you wanted, 11 plus 9 plus 11 plus 9 plus 11 plus 15. Okay, and then we would add all of those together, and when I have a huge group like that, it's much easier for me to take this here and actually just get my calculator to do it. And I probably would do it a couple times to make sure I did it right. So my perimeter is 114 and it is millimeters. Okay, so make sure you always finish with a unit of measurement. Okay, so lots of examples from the textbook for you to do tomorrow.